Om Swastiastu, salam sejahtera. Saya, Rektor Universitas Udayana, menyatakan bahwa Universitas Udayana berkomitmen penuh melawan penyebaran virus COVID-19 dengan beberapa langkah. Yang pertama, Universitas Udayana telah menyiapkan dasar regulasi aksi dengan menerbitkan instruksi rektor tentang pencegahan, perkembangan, dan penyebaran COVID-19 di Universitas Udayana. Kedua, Universitas Udayana telah membentuk Satgas Pencegahan COVID-19. Ketiga, Universitas Udayana melalui Satgas telah menyusun dan menyebarkan panduan pencegahan, protokol, dan SOP yang berlaku di Universitas Udayana. Keempat, Universitas Udayana juga melakukan aksi nyata dengan menyebarkan hand sanitizer ke seluruh unit di Universitas Udayana. Penyemprotan atau sterilisasi serentak pada gedung dan ruang di lingkungan Universitas Udayana, menyediakan layanan konsultasi, pelaporan melalui call center dan hotline di nomor 0361 895 3670. Untuk kegiatan belajar mengajar telah dilakukan melalui sistem online. Tenaga kependidikan pun telah diterapkan bekerja dari rumah. Saya selaku Rektor Universitas Udayana menghimbau kepada seluruh sivitas akademika dan masyarakat umum untuk mengikuti protokol pencegahan yang dikeluarkan oleh pemerintah seperti mengurangi kegiatan di luar ruang, social distancing, rajin mencuci tangan, dan selalu menjaga kesehatan. Demikian saya sampaikan, salam sehat selalu. Om Santi 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 Om. Om Swastiastu, salam sejahtera. Saya, Rektor Universitas Udayana, menyatakan bahwa Universitas Udayana berkomitmen penuh melawan penyebaran virus COVID-19 dengan beberapa langkah. Yang pertama, Universitas Udayana telah menyiapkan dasar regulasi aksi dengan menerbitkan instruksi rektor tentang pencegahan, perkembangan, dan penyebaran COVID-19 di Universitas Udayana. Kedua, Universitas Udayana telah membentuk Satgas Pencegahan COVID-19. Ketiga, Universitas Udayana melalui Satgas telah menyusun dan menyebarkan panduan pencegahan, protokol, dan SOP yang berlaku di Universitas Udayana. Keempat, Universitas Udayana juga melakukan aksi nyata dengan menyebarkan hand sanitizer ke seluruh unit di Universitas Udayana. Penyemprotan atau sterilisasi serentak pada gedung dan ruang di lingkungan Universitas Udayana. Layanan
the second JMRT webinar series entitled Nature-Based Solution for Climate Change Mitigation, Seagrass, their potential. Let me introduce myself. My name is Giri. I am the person in charge during this seminar session. And first, I would like to thanks to all participants, the speaker, and all of the Faculty of Marine Science and Fisheries member, particularly to our Dean, Vice Dean, the Coordinator Study Program of Marine Science, and the Center for Remote Sensing and Ocean Science for supporting this event. For this event, we have 4 speakers, and the number of the speaker is suddenly remind me with my favorite Marvel superhero. Yeah, maybe some of you know that there's a Fantastic Four. So I think we can call the speaker is the Seagrass Fantastic Four. And our speaker comes from several institutions. In Australia, we have Dr. Mike Van Kulen from the Murdoch University. First, I would like to say hello to Dr. Mike. Halo, Dr. Mike. Selamat pagi.
Selamat pagi.
Okay. And from the eastern part of Indonesia, we have Professor Ricardo F. Tapilatu from the University of Papua. Selamat pagi, Pak Ricardo. Okay. Any trouble with the connection? And in the middle part of Indonesia, we have Ibu Elok Faikoh MSI from the Udayana University. Selamat pagi, Ibu Elok.
Selamat pagi, Pak Giri.
And finally, the western part is represented by the Coordinating Ministry for Maritime and Investment Affairs, Dr. Andreas A. Huta Hayan. Selamat pagi, Pak Andreas.
Selamat pagi, Bli.
Ya, terima kasih. The number of participants who registered for this webinar was 696 participants from 155 institutions. Some of the participants will join us with the using the Udayana TV and YouTube channel. And the institutions are the Udayana, Universitas Udayana, IPB University, Universitas PGRI Ranggolawe, Universitas Tribuana Kalabahi, Universitas Hairun, Yayasan Lini, Universitas Palangkaraya, Universitas Tribuana Kalabahi, Universitas Negeri Gorontalo, Janus Lab, Politeknik Pertanian Negeri Kupang, Universitas Bosowa, Universitas Bangka Belitung, Yayasan Kalimajari, Universitas Brawijaya, Sekolah Tinggi Ilmu Pertanian Muhammadiyah Sinjai, Universitas Patimura Ambon, Universitas Muhammadiyah Lubuk Banggai, Universitas Teguh Umar, Politeknik Indonesia Venezuela, Politeknik Kelautan dan Perikanan Sidoarjo, Universitas Malikul Saleh, Politeknik AUP Jakarta, Dinas Kelautan dan Perikanan Kabupaten Aceh Barat, BRSDM KP, BBR BLPP Gondol, Universitas PGRI, BPPP Tegal, Politeknik Perikanan Negeri Tual, Universitas Islam Lamongan, Kementerian Kelautan dan Perikanan, Universitas Riau, Universitas Lampung, Universitas Hasanuddin, Handrio Nur Asia, Universitas Muhammadiyah Malang, Universitas Teguh Umar, Universitas Trunojoyo Madura, University of 45 Mataram, BPU 2K, Universitas Patimura, BPP Banyuwangi, Sekolah Tinggi Perikanan dan Kelautan, Institut Teknologi Yogyakarta STTL YLH, Dinas Perikanan Kabupaten Buton Utara, Universitas Borneo Tarakan, Universitas Gorontalo, Dinas Kelautan dan Perikanan Kabupaten Pati, Universitas Jenderal Sudirman, Universitas 17 Agustus 1945 Cirebon, Universitas Muhammadiyah Makassar, Research Institute for Ornamental Fish Culture, Minister of Marine and Fisheries Affairs, Sekolah Tinggi Perikanan dan Kelautan Palu, Politeknik KP Maluku, Telkom University, Fish Quarantine and Inspection Agency of Yogyakarta, Balai Besar Riset Budidaya Laut dan Penyuluhan Perikanan Gondol Buleleng, Aceh Coral Conservation, Indonesian Maritime Yacht, Politeknik Halmahera, North Buton Regency Fisheries Service, Universitas Muhammadiyah Surakarta, Balai Besar Taman Nasional Teluk Cendrawasih, Universitas Papua, PPS Kendari, Lab Tes Online Australia, Universitas Diponegoro, Universitas Haluleo, Cabang Dinas Kelautan dan Perikanan Kabupaten Situbondo, Cabang Dinas Kelautan dan Perikanan Kabupaten Tuban, BP3 Ambon, BRSDM KP, Suku Dinas Ketahanan Pangan, Kelautan dan Pertanian Jakarta, Universitas Samratulangi Manado, BRP BAP3 Maros, Misi Bahari, Universitas Gajah Mada, SUPM Waiheru Ambon, Institut Teknologi Bandung, Dinas Kelautan dan Perikanan Aceh Selatan, Dinas Kelautan dan Perikanan Kabupaten Aceh Barat, Politeknik Kelautan dan Perikanan Karawang, Unimal, Pusat Riset Perikanan, Dinas Perikanan Kota Mataram, P4TK Pertanian, UIN STS Jambi, Universitas Sriwijaya, Dinas Kelautan dan Perikanan Provinsi Kepulauan Riau, BRP 2 UP2 Palembang, UMI Makassar, LIPI, Universitas Pendidikan Ganesha, Satminkal BP3 Ambon, Universitas Nahdlatul Ulama Kalbar, BP3 Tegal, Sekolah Tinggi Teknologi Kelautan, Universitas Lambung Mangkurat, Dinas Pangan, Pertanian dan Perikanan, kemudian Bau-Bau Politeknik, Unsulbar, BPSPL Makassar, Universitas PGRI Palembang, Universitas Kristen Wirawacana Sumba, Akademi Komunitas Kelautan dan Perikanan Wakatobi, MMAF, Langko Diving Club, Universitas Maritim Raja Ali Haji, Dinas Perikanan Kabupaten Mamberamo Raya, Universitas Muhammadiyah Luwuk, Department of Environment, Land, Water and Planning, Universitas Mataram, Balai Riset Budidaya Ikan Hias, Politeknik Negeri Nusa Utara, Universitas Cendrawasih, Politeknik Negeri Nusa Utara, Universitas Heina Motemo, BP3 Medan, Politeknik Bau-Bau, Ispikani Kepri, BRP BATPP Bogor, Dinas Kelautan dan Perikanan Kabupaten Bima, Balai Riset Pemulaian Ikan, Institute for Marine Research and Observation, IMRO, Center for Fisheries Research, Nusa Cendana University, Ministry of Marine Affairs and Fisheries, Fakultas Bioteknologi UKDW Yogyakarta, and so on. And for your information, next issue of our journal, Journal of Marine Research and Technology, will schedule on August 2020. So we invite you all to submit your manuscript to our journal. And now we will move on to the next session. The next session will be the opening speech delivered by the Dean of the Faculty of Marine Science and Fisheries, Professor Artane. To Professor Artane, time is yours.
Good morning.
Good morning, Pak.
Good morning.
Om Swastiastu. Assalamualaikum warahmatullahi wabarakatuh. Namo Buddhaya. Salam sejahtera buat kita semua, to all of us. Ladies and gentlemen, on behalf of Faculty of Marine Science and Fisheries, Udayana University, Bali, I would like to say thank you very much, particularly to all of my distinguished speakers, like Dr. Mike Van Pulen from Murdoch University, Dr. Andreas Sutahian from Menko Kemaritiman. Nanti kerjasama lagi Pak ya.
Iya, Pak.
Dr. Mike Van Pulen, I met more than once, I think, in Udayana University. Ibu Ella from my faculty, and then Professor Ricardo Napilatu from University of Papua. Thank you very much. To all participants, also I need to say thank you very much wherever you are now. Many thanks for joining this webinar. On this occasion, let me introduce shortly of Udayana University in Bali. Udayana University in Bali is the biggest university in Bali, of course. We have 13 faculties, 13, and one postgraduate programs. There are more than 100 study programs in Udayana University, including bachelor, master's, and PhD program. The student body of Udayana University is around 27,000 with 900 staff, 900 staff, and 1,600 lectures. In Bali, we have 3 campuses, 2 in Denpasar City, and 1 from Bukit Jimbaran campus. I myself, now, I am speaking from Bukit Jimbaran campus, situated 22 kilometers from Denpasar City. Meanwhile, the host speaking from Denpasar City. The Marine Science, the Marine and Fisheries Faculty itself has 2 study programs, namely Marine Science and Aquatic Resource Management, with over 600 students and 32 lectures. That is a brief introduction about my university and my faculty. To all speakers and participants, I do hope through these webinars it will strengthen the cooperation between all of us in the future, like with Mordok University, with Papua University, and also Menko Kemaritiman. I do hope. To participants, we are very open to cooperation. I heard a lot of university joining in this webinar, so I'm very glad to hear that. More than 700 around. Especially, we need cooperation related with the independent learning program. In Indonesia, we call it program Merdeka Belajar. It's very new. This is that requires the exchange of courses between student programs for our students at different university in the very near future. So our students have to learn lectures from different study programs in different university. So this is a very new program from our ministry. I think that's all what I can say. Hopefully in this you all will receive a lot of new inspirations, new ideas, and good communication and discussion. So I conclude by saying thank you very much and see you again. Thank you.
Thank you, Professor Artana. Now we will move to the presentation session. So during this session, each speaker will present their material approximately 15 minutes, and the discussion session or question and answer session will be open after all the speakers finish their presentation. But during the presentation, the participants are allowed to write their question in the Zoom chat room or in the YouTube channel. And for to keep this webinars conducive, I suggest to all participants to mute their microphone And the first talk will be given to Dr. Mike Van Kulen. And while we are set up for the mic presentation, I will introduce to you all to the Dr. Mike. So the Dr. Mike is an the Dr. Mike is an associate professor in marine biology and plant science at the Murdoch University. He is also the director of Coral Bay Research Station, which is based in Western Australia. He also has some diving certificates, such as Master Diver and Diver Supervisor, certificate to provide oxygen in dive accident, medical certificate for professional diving, and so on. And what is interesting for me about Dr. Mike, because he has some awards in teaching experience. So I guess he is one of the most inspiring lecturer at the Murdoch University. And of course, he had a lot of works regarding to seagrass in Australia and around the world that he will share with us today. So please welcome Dr. Mike.
Thank you, Pak Giri, and selamat pagi. Today I will be talking to you a little bit about what seagrasses are and what the losses of seagrasses have been, their threats, and what we can do in the future. I will be talking a little bit about seagrass restoration, which is how we can help the seagrasses come back where they've been damaged. I will start with a little bit of information about what seagrasses are. Seagrasses are underwater flowering plants, so they have evolved to live in the marine environment. They have adapted to a saltwater environment, and they grow their entire life history completely underwater. They produce flowers underwater, so they are flowering plants like our terrestrial plants, but they flower underwater. We have about 72 species of seagrass around the world, and these can be split into tropical species and temperate species. The tropical species are very widespread, and we have many of the same species throughout the Indo-Pacific region, so from Africa across to Southeast Asia. And they also extend north to Southern Asia and also south to parts of Australia. One of the interesting things about the tropical species is that most of the tropical meadows have many different species growing together in them. As you can see in the left-hand photograph here, this is a photograph from seagrass meadow in Bali. There are probably about 8 species of seagrass growing all together in this one meadow. In temperate areas, so where I live in southern Western Australia, we have the right-hand photograph, which is a species, just one species, making a very big meadow of many hectares, but only one species. So that is a big difference between the temperate and tropical seagrass species. The structure of the seagrass is shown here. And one of the important things about seagrass is the rhizome. So they have a rhizome that runs under the sediment. It is an underground stem that runs under the sediment, and every so often we have shoots of leaves that come up to above the surface and photosynthesize. Underneath from the rhizome are roots, which are useful in absorbing nutrients. So in this way, they spread out across the sand and colonize large areas. The photograph at the bottom shows you a piece of seagrass that was collected from South Australia. And you can see the rhizome at the bottom here and the shoots which photosynthesize coming up. Seagrasses are important in our coastal ecosystems. They have many different functions, and I believe we will see more about this from other speakers. But some of the major functions that seagrasses provide. The first thing is seagrass is a complex three-dimensional habitat. They grow in bare sand, which is flat, and there is no shelter there. So if the seagrass is growing above the sand, we have a complex three-dimensional habitat which allows a nursery for young fish. It provides protection from predators and provides a shelter. And this includes many important fish species that are used for food and for commercial fishing. You can see in the photographs the many different types of animals that are associated with the seagrasses. The next important role that seagrasses provide is sediment stabilization. The rhizomes anchor the plants in sand and mud. And you can see in this photograph here, taken in the Maldives, seagrass have grown from a seed and are spreading out into the bare sand using their rhizomes. So here you can see a rhizome with many shoots coming from it. And this is how they spread out over the surrounding sand. And this helps to stabilize the sediment. It holds the sand in place. The other thing that they do is seagrasses, because they have a three-dimensional structure, as the water flows into the seagrass meadow, any sediment that is carrying falls out. The water slows down and the sediment falls out. And so we have a buildup of sediment underneath the seagrass. In the photograph on the right, you can see a Posidonia meadow from Perth in Western Australia, which has banks of sediment that have built up. And these banks can be over a meter from the surrounding seabed. It's not just big seagrasses that do this. So here we have an example of small Halophila ovalis, which is very common in Indonesia, doing the same thing. This is at Ningaloo Reef in Western Australia. And you can see the small seagrasses are actually allowing the sand to build up. This is very important because it holds the sediment in place and stops coastal erosion. The photograph on the right shows rhizomes of seagrass where the seagrass leaves have died. So once the seagrass leaves die, the rhizomes stay under the sediment and hold the sediment in place. And that can last for thousands of years. They can hold the sediment in place. So very important for protecting our coastline, especially when we have climate change and rising sea levels. We need to have something to hold the coastline in place, and seagrasses help with that. They also contribute to what is called blue carbon. So the rhizomes contain carbohydrates which are locked under the sediment and remove the carbon dioxide from the water column, from the atmosphere, and hold it under the sediment, so helping against climate change. Of course, seagrasses are very productive. They produce a lot of biomass and grow quite quickly, especially in the tropics. And they are an important food for animals like dugongs and also turtles. But only 20% of the seagrass is eaten. Most of the seagrass leaves become detritus, so they die without being eaten, and they wash up on the beaches, as you can see in these photographs here. When they're washed on the beaches, the bacteria break down the seagrass material and recycle the nutrients back into the ocean, which is very important because seagrasses and associated coral reefs and other habitats are usually in nutrient-poor waters. So the recycling of nutrients is very important for the ecosystem. Seagrasses are under threat. They have been declining globally for the past 100 years. So human activity has been causing the loss of seagrass over the last 100 years. In 2009, it was estimated that 29% of the world's seagrass has been lost. And we are currently losing about 7% of the world's seagrass every year. The information that was used to make this report relied on many, many publications, but there are some big knowledge gaps in our publications, and the biggest knowledge gap is for the Indo-Pacific region. So the region that includes the Indian Ocean and the Pacific Ocean. So this is a big gap in our knowledge. And of course, this is an area where we have a lot of seagrass. The most seagrass in the world is in this part of the world. And so it is important to collect extra information about this region so that we have a better understanding of the threats of seagrass and the status of seagrass around the world. So there are many different threats to seagrass. There are some large-scale threats and some smaller-scale threats. The large-scale threats are more difficult to control, but can be controlled. And I'm not talking about climate change here. I'm talking about things that occur at a regional sort of scale. The first of these is land reclamation. This is a Google Earth photograph of Benoa Harbour showing some of the land reclamation that's going on there. And as part of that reclamation, you can see the white areas, which are the sand that's been built up for the harbour development. That has been put on top of seagrass meadows and is removing mangroves and seagrasses from that area. A second major threat to seagrasses is deforestation. So we have deforestation from logging, from agriculture, from creating palm oil plantations and so on. When we do this deforestation, the topsoil of the land is lost and it moves into the rivers, and then the rivers put this sediment into the coastal waters. That creates a lot of turbidity, and therefore it is too dark. There is not enough light for the seagrasses to grow. And so this is a big problem in areas where there is a lot of deforestation. The third big threat that has occurred in the past, but is not so much of a problem now, is something called wasting disease. So this is a disease caused by a slime mold, which kills the seagrass leaves, and the seagrasses die. This was a big problem in the North Atlantic Ocean, so North America and Europe, in the 1930s and a little bit after that. But it now seems that the problems were affecting the seagrass before the disease came in. So things like too many nutrients and also increasing water temperatures may have affected the seagrass and allowed the disease to affect them. The final and biggest problem around the world is eutrophication. So this is where there are too many nutrients in the water, and the algae that are growing around the seagrasses take up the nutrients more quickly and therefore smother the seagrass and stop them from growing. We also have problems with too many nutrients causing plankton blooms, which can also kill the seagrass. So this is actually the biggest cause of seagrass loss around the world, according to the reports that have been published so far. In addition to the larger seagrass threats to seagrass, we also have some small-scale threats. These are much easier to control through fishing regulations and local management. So the first of these is fishing. Fishing pressure, if you're catching fish or if you're harvesting clams or other animals from the seagrass meadows, can cause some damage to the seagrasses. The second threat is from boating. This is a photograph of the scars and damage caused by boats in Lembongan Island, where the tour boats moor at night. They are up in the seagrass meadows and they damage the seagrass. We also have problems with anchor damage and boats running through the seagrass and digging up the seagrass. So this is a big problem in many places around the world where we have shallow seagrasses. The third problem is seaweed farming. I know there is seaweed farming at Lembongan and Cheningan Islands of Bali. This photograph is from Tanzania, but the same sort of thing. So they are farming for seaweeds and they put the fences that they use for the farming in the middle of seagrass beds, and that can cause quite a lot of damage as well. And then finally, for the small-scale threats is aquaculture. So this is a photograph of oyster aquaculture in southern New South Wales in Australia, but we also have problems with big fish cages where the fish are fed and the nutrients, the excess nutrients, fall to the seagrass and cause problems with eutrophication. So those are the major problems, but we can do something about them. And I just want to finish this talk with a little bit about seagrass restoration. The first thing to do is to fix the problem that caused the loss of seagrass. Many seagrasses will grow back by themselves without any help from us, but we can help make them grow back faster. So there are many different methods available, and that depends very much on the local conditions, where you're trying to restore the seagrass, and also the species of seagrass that you want to restore. So this slide shows some work that we have done in southern Australia, trying to restore seagrasses using manual transplants of pieces of rhizome with leaves on them. And using this method, we transplanted over 3 hectares of seagrass. It takes a lot of people, it takes a lot of work, and obviously it could potentially be expensive, although we used many, many volunteers to do this work. And we transplanted over 3 hectares, but in the area that we were transplanting, we had already lost over 1,000 hectares. So the scale of this is quite small compared to many of the losses that we experience. But it is effective, and in the next slide, we can see what we can produce after 5 years of growth after transplanting. So we've produced a nice, dense seagrass meadow fairly quickly. If we're working in higher energy, higher wave energy areas, we use larger transplants. And so the example that I've got here is of a core, which we push into the ground, and we dig it up, and we have what is called a plug of seagrass. And this includes the seagrass plants, the rhizomes, and also the sediment surrounding it. And that makes it much stronger and much more resistant to wave energy. The big photograph shows an experiment that we were running in a high wave energy area. And you can see the plants are living quite happily under those conditions. We can expand that further to use mechanical methods as well. So we have produced machines in the past that do the same thing, but bigger blocks. What we're looking at now is using seeds and seedlings to be more efficient at restoring seagrasses around in areas where they've been lost. So this allows us to restore seagrasses in bigger areas and more cheaply and with less people involved than manual transplant methods. So the photograph at the bottom here shows some seagrass restoration in North America, where they're transplanting seeds of Zostera marina, which is their major seagrass there. They produce seeds, and many seagrasses actually produce seeds that fall into the sediment and form what is known as a seed bank, and they grow back from those seeds each year. We can collect those seeds and then spread them into areas that we want to restore. The top two photographs show Halophila ovalis, which is a common tropical seagrass, which also produces these sorts of seeds. And you can see the fruit in the left-hand side inside that circle. In the right-hand photograph is my finger with a dive glove and showing the fruit with the seeds inside it. And the seeds are about half a millimeter in size, so very small, but they can survive for up to 4 years. So that means we have a lot of flexibility in how we can restore seagrass meadows using seeds. The next step is to move from seeds to seedlings. And so what we're working on at the moment in Western Australia is transplanting or restoring seagrass meadows using seedlings. So there are many seagrasses that do not produce seeds that form a seed bank, and instead they keep growing once they've produced a fruit. And here you can see Posidonia australis, which is a common seagrass in Western Australia. The top right photograph shows the seedling. So this is contained inside the fruit. The fruit opens and the seedling drops to the bottom and starts growing straight away. And at the bottom photograph, you can see one of the seedlings with the seed coat still attached to it. We're currently looking at ways of harvesting these seedlings and culturing them on land and then moving them out into the environment. So this, together with the seed bank approach, would allow us to restore larger areas of seagrass much more quickly and gives us much better chance of restoring coastal habitats. That is my last slide. I'll leave it at that and happy to take questions at the end of the talks. Thank you very much. Terima kasih.
Thank you, Dr. Mike, for sharing your interesting work about seagrass restoration in Australia. And for the second speaker, we have Dr. Andreas A. Hutahayan. So Dr. Andreas is currently working as Deputy Director for Marine Conservation and Small Island Utilization at the Coordinating Ministry for Maritime and Investment Affairs, Republic of Indonesia. Dr. Andreas has expertise on marine biogeochemistry of blue carbon and blue economy. He completed his bachelor degree from Department of Marine Science, IPB University. His master degree was from Uni Bremen, Germany in 2002 on marine chemistry, and the PhD degree was from the University of Nagoya, Japan in 2010 on marine biogeochemistry. And now he also a lecturer at Marine Science Postgraduate Program at IPB University. And he was also one of the pioneer in developing Indonesia Blue Carbon Program and a negotiator for ocean in UNFCCC meetings. And today, Pak Andreas will share with us about the blue carbon in Indonesia. Pak Andreas, are you ready to present your work?
Yes, sure. Can
Yeah.
I share my slide from here?
Yeah, okay, sure. Please, Pak Andreas.
But the host disabled me to share the screen.
Yeah, wait a moment, Pak Andreas.
Okay.
We will handle it.
Yeah, for the time being, I think I would like to give thank you to Pak Mike for bring the very good introduction about what is the seagrass about, from the physiological and then the treat, something like that, and then also raise issue about the restoration of seagrass ecosystem in Australia, and which is very important. I think you already mentioned that about annually about 7% loss of the seagrass already happening now in many places globally. So I think what you already mentioned bring us a wake up call, something like that. That how is the situation at the moment, and and then follow up the mic. I think I would like to share some information regarding uh, about climate change mitigation of the seagrass. Can you see the slide from here?
Yes, we can see it.
And my voice also is okay?
Yeah, okay.
Okay, thank you. Yeah, I would like to share some information. How is the role of the seagrass to control or to mitigate our climate change uh, globally, something like that? And I think, and how is where is the source actually of this carbon in the seagrass ecosystem? I will also let you know from the some study location in Indonesia. My name is Andreas, Pak Giri already mentioned, and I'm working under the Coordinating Ministry for Maritime and Investment Affairs, Republic of Indonesia. This ecosystem services already mentioned that seagrass brings many things. So, including, maybe you can see here. Let me pen color. Maybe you can see here the function of the seagrass. Many things, including the important thing is about the carbon sequestration in the coastal or marine environment. So many people say that seagrass is the underwater lung, something like that, and because previously speaker already mentioned that all lifetime of the seagrass they are stay underwater in the seawater, something like that. So it's a very good reason that why we should take care the underwater lungs. And below, I think below here you can see also how how the comparison about 1 acre of the seagrass is about 0.5 or 0.4 hectare of seagrass can absorb about 3,000 more kilogram of carbon CO2 per year, which is equivalent to maybe one small car about 6,200 kilometer riding, and provide those big important contribution to our planet. Uh, this figure telling us how is the seagrass is distributed globally, and we can see here that the position of the Indonesia and Australia, and then is the central, the core of the biodiversity of the seagrass globally. So it's estimated about more than 177 kilometers square of the seagrass globally, and there are about 24 species, and 15 of the species are located in Indonesia. So this is a big number. How the diverse of seagrass ecosystem in the Indonesia alone. Then let me come to the blue carbon. I think most of us are already familiar with the terminology of the blue carbon. I think blue carbon, by simple understanding, that is the carbon or CO2 captured by living organism in the coastal ocean ecosystem through the photosynthesis process, and then it accumulated in biomass and then in sediment. So the key point of the blue carbon is the photosynthesis process, how they could absorb CO2 and then release the O2 in our water column. And then many of the living organisms could enjoy the abundance of the dissolved oxygen in the water column. And uh, why here the importance of the coastal marine ecosystem for the climate change mitigation and adaptation? I think we know already that these two different names, we call it adaptation and mitigation. So uh, actually, our coastal ecosystem, like seagrass, is not standalone for mitigation. But before, I think there's many ecosystem services that already do the adaptation for climate change. Something like for food security, already mentioned that how abundant the juvenile of fish in the coastal in the seagrass ecosystem, and also they could provide the resilience, I mean, protecting the coastal from the current and so on. And another aspect is the mitigation, like a blue carbon. Then how the seagrass ecosystem could able to absorb the greenhouse gases in water column in their environment. These are the I would like to explain here. Although you can see this is not really like sea grasses, but assuming this is a seagrass anyway. This is carbon dynamic in the coastal vegetation. In the carbon dynamic terminology, there are three the main topic. First, we call it sequestration. This is the coastal vegetation, mangrove or seagrasses take up the CO2 from the atmosphere or from the environment, from the water column, and do the photosynthesis. And then the CO2 stored in their body of the vegetation and becoming growth, becoming the leaf, stem, and branch, and so on. And then if we destroy or of the vegetation of the process or the ecosystem being cutting or what destroyed by human activities or natural disaster, something like that. So the CO2 can be released back to the environment, either to the water column or to the ocean, to the atmosphere. This figure telling us how good, how efficient that the coastal ecosystem could absorb, sequester the carbon in the environment. In the left side, I think here you can see the annual sequestration of the coastal ecosystem, mangrove, tidal marshes, seagrass meadow, in comparison with the terrestrial forest, either in the tropical or in the subtropical or temperate forest. And below is how the burial rate of the seagrass of coastal ecosystem, mangrove, and salt marshes in comparison with another terrestrial forest. they are very much different. And on the right side, you can see that it's very abundant that the ability of our seagrass and mangrove ecosystem could store the CO2 in the water, in the sediment, or in the as biomass in the above ground. So these are two of recent study conducted by Rahayu and Kusumaning Tias about how the role of the seagrass ecosystem and mangrove ecosystem being taken up the CO2 from the environment in Indonesia. And if we are cutting two different previous slides like follow here, that actually what we see from the surface above the ground, above the below ground, is about only 20 to 30% of the original carbon being absorbed by the vegetation. So the remaining, the highest things is in the sediment. It's about 70 to 80%. Either it is a seagrass ecosystem or in the mangrove ecosystem. So this is evidence that why we need to take care that how it's good, how to take care of the ecosystem so that the sediment is not exposed to the environment, so they could not release the CO2 back to the nature, something like that. This paper summarized from the what we call it the paper produced by the Alongi 2015. This is mentioned how abundance of the blue carbon in Indonesia. So in the left side we can see this is the mangrove ecosystem. And then the ability to store the mangrove on average about 950 megagram carbon per hectare, while on the seagrass ecosystem about 119 megagram carbon per hectare being stored in the seagrass. So the seagrass number are coming from what study has been done by Alongi et al. In 2015. These are some study that Alongi study of the sample are being taken from different area of Indonesia, but it's not many area actually. Mostly in some part in Jakarta, in the Thousand Islands, Banten Bay, and in the East Kalimantan, some in maybe in Lombok, and then in the Sulawesi. So, but this is the number of summary of this paper. And I would like to share you a bit detail about the seagrass in one of the important area in Indonesia. Is in the Spermonde Archipelago, or we call it Spermonde Island, located in the southern part of Sulawesi. You can see in the below where is the Spermonde Island is located, and we take some experiment in the 4 different islands, small island off of the Sulawesi. And from the location, we take the sediment core in 4 different islands. Can you hear my? Sorry, Beli bisa dimatiin nggak yang lain? Here is the downcore profile seagrass in the sediment at the 4 different locations.
Mohon maaf Pak Andreas, hostnya tadi terpindah ke Pak Andreas. Mungkin bisa dikembalikan ke Pak Hendrawan. Host Zoom-nya terpindah ke Pak Andreas.
Oh ya?
Ya. Bisa minta tolong dipindahkan ke Pak Gede Hendrawan lagi.
tanya, klik partisipannya Pak Andrea, klik
Ya.
partisipan, klik
Di
partisipannya,
partisipan, klik di
Oh,
bagian
partisipan ya.
Ya,
ya, klik
partisipan.
partisipan, kemudian nama saya Gede Hendrawan,
Iya.
kemudian di sana klik ada more,
Ada apa?
Iya, di sana host. Gitu.
Make host ya.
Ya, tadi terklik tadi. Ya, oke. Ya.
Udah.
Oke.
Ya, oke. Silakan lanjut Pak Andreas.
Okay. So these are some down core profile has been taken from 4 different islands that I have previously mentioned. There are Barang Lompok, Kapoposang, Bauluang, Sarapo, Keke. So we're taking a profile, but it's not, because of it's mostly our sand, the sediment are made of the sand. So it's not, it's very difficult to have a very good or deep coral, sediment core profile. But the maximum profile is about the 55 centimeter is in Barang Lompo, but other is less than 40 centimeters. We measure the difference of carbon density, percent of the organic carbon, CN ratio, delta C13, and also delta N15 from the sediment in that area. And from this that kind of profile, we were able to trace the sediment. Where is actually the organic carbon coming from? Using the ratio composition between C13 delta C carbon C13 and also CN ratio by plotting in the one biplot, something like that. In the left side, you can see that the paper published by Khan 2015. This paper bring information how we could able to trace the source of the carbon or the organic carbon in the different environment. At the left side, we can see that how is the marine phytoplankton source of carbon, and then on the in the y-axis, I think here, how is the freshwater influence of the carbon in particular in the what we call it in the environment. While in the middle, we can see how is the seagrass mostly or the marine environment influence of the organic carbon, something like that. So based on this kind of this study, we could try to plot the delta C13 and then CN ratio into the plotting. So in this area, we could able to find that most of the organic carbon in these 4 islands are coming from mostly are from the ocean, and there is very less or very limited influence of the carbon coming from the terrestrial, something like that, either through the runoff or whatever reason. So this is very important when we can trace back what is the source of the sediment, organic carbon in this particular area, especially in the small island. And next, you can see also the composition. These are telling us the contribution of different and members to the seagrass sediment organic carbon. So most of the sediment organic carbon in these 4 islands are coming from the seagrass leaf. So, and yeah, it's more than roughly about 70% are from seagrass leaf, and very small coming, unless in the Gua Luang, very small are coming from the what we call coastal particulate organic matter or terrestrial based organic carbon. So this is telling us that most of the carbon is actually coming from their own environment, something like that, in the particular area. So this figure, again, I will tell you that this figure telling us how good is the difference that total carbon stock in the Spemoli Island under 4 different islands here in Baranglompo, Sarapokeke, Kapoposang, and Bauluang. So this paper telling us that about 70% or even more, maybe more than 80% of the carbon stock in this environment were coming from actually they stay in the sediment rather than as the biomass. This is very reasonable because the biomass of the uh, seagrass is not really much abundance, something like that. It's not very high carbon content in comparison with what is already being detritus or being what stored in the sediment in this particular area. I think these are my presentation. Thank you very much, moderator, for giving this opportunity. I back to you now. Thank you, Pak.
Thank you, Pak Andreas, for your valuable information regarding to the blue carbon, especially the blue carbon of the seagrass. And now the third speaker is Ibu Elok Faikoh, MSE. The name sounds very familiar to me because she is my colleague in the Udayana University. So Ibu Elok is the lecturer at the Faculty of Marine Science and Fisheries, Udayana University. She is also the head of Marine Science Laboratory in Faculty of Marine Science and Fisheries, Udayana University. Bu Elok get her bachelor degree from the Department of Marine Science and Technology, IPB University, and the master degree was from Environmental Science Master Studi Program, University of Indonesia. And during his career in Udayana University, she has a lot of work regarding the seagrass ecosystem in Bali. And we have a privilege to hear about her works in this webinar today. So, Bu Elok, are you ready to present your work?
Yep, thank you, Pak Giri. Maybe I
Please,
will
Bu Elok.
present mixed with bahasa because I saw in participants mostly is from Indonesia, and it would be great for me to present in bahasa.
Yes, great.
Okay, thank you, Pak Giri. I will start my presentation. Selamat pagi, Bapak Ibu semuanya. Saya akan mempresentasikan tentang seagrass atau status dari seagrass di perairan Bali khususnya. Saya membuat judul Seagrass the Intertidal Warrior. Kenapa judul ini yang saya pilih? Karena memang ketika akan masuk ke laut, pejuang pertama yang melindungi daratan itu adalah seagrass. Kita akan lihat bagaimana status dan threats dari seagrass di perairan Bali. Kenapa seagrass? Tadi speaker sebelumnya Pak Andreas sudah menjelaskan dan Pak Mike sudah menjelaskan mengapa pentingnya seagrass bagi ekosistem laut atau bagi manusia khususnya. Saya mendapatkan gambaran ini dan menurut saya ini cukup menarik karena kita melihat di bagian intertidal, seagrass ini hidup di daerah intertidal dan seagrass ini merupakan productive area. Dia memberikan keuntungan bagi manusia dan juga hewan-hewan yang tinggal dan mungkin menggunakan jasa dari ekosistem seagrass tersebut. Pak Andreas tadi sudah menjelaskan tentang spesifik dari ekosistem services yang seagrass berikan untuk karbon khususnya. Kalau saya akan lebih menyeluruh, di Bali khususnya, yang saya lihat Seagrass Services ini, Seagrass ini memberikan servis yang sangat luas karena dia memberikan tempat tinggal, tempat berlindung, dan tempat mencari makan bagi hewan-hewan baik yang dilindungi ataupun hewan-hewan kecil lainnya, dan itu sangat berguna bagi manusia. Lalu di Bali sendiri banyak bisa kita sebut nelayan, tapi sepertinya dia bukan nelayan secara khusus, karena dia cuma mencari ikan setiap pagi, dan itu dia mencarinya di daerah Seagrass. Lalu Bali sebagai pariwisata, tentunya Seagrass ini sangat mendukung keberadaan pariwisata di Bali, karena dia memberikan, kalau memang kita lihat Seagrass itu nggak indah, tapi organisme yang tinggal di Seagrass, di Bali sendiri khususnya, itu sangat menarik. Saya sebutkan beberapa. Ini adalah beberapa organisme yang kami temukan di Bali. Dari Echinodermata, moluska, jenis-jenis ikan, dan juga kalau biota yang dilindungi ada dua yang yang ada di Bali, yaitu pertama adalah dugong-dugong dan juga penyu. Lalu bagaimana distribusi dari Seagrass di Bali? Ini adalah peta keberadaan Seagrass yang ada di Bali. Ini saya lakukan pengambilan datanya selama 2 tahun. Dan dari seluruh pulau Bali, Seagrass tinggal atau banyak terdapat di daerah utara agak ke barat dan juga daerah selatan. Lalu di sebelah timur itu ada di daerah Pulau Lembongan, dan juga satu lagi sebenarnya ada di Pulau Nusa Penida. Dan di Bali sendiri, jenis Seagrass kurang lebih saya temukan ada 9 spesies. Dan itu tersebar di beberapa tempat. Tipikal dari Seagrass yang ada di Bali itu terbagi 2. Ada kebanyakan adalah mixed species, artinya satu spesies Seagrass tinggal bersama dengan spesies yang lain. Dan ada 1 atau 2 tempat yang saya menemukan monospesies. Jadi hanya yang berada di sana hanya jenis Halophila ovalis. Ini adalah Seagrass spesies yang ditemukan di Indonesia, dan di Bali sendiri saya sebutkan tadi ada 9 spesies ditemukan. Di Indonesia ada 16 spesies yang ditemukan. Sebelumnya kita mengetahui Seagrass di Indonesia itu ada 13 spesies. Yang terakhir diberitakan itu adalah Halophila sulawesi. Namun beberapa tahun berikutnya setelah Sulawesi ditemukan, secara genetically spesies yang tadinya tidak terlihat keberadaannya di Indonesia, dia ditemukan atau dia teridentifikasi berada di Indonesia secara DNA, yaitu Halophila beckeri, Halophila Meyer, dan Rupiah maritima. Kalau Rupiah maritima ini Seagrass-nya ada disimpan di LIPI Jakarta. Gambar di sebelah ini adalah gambar-gambar dari Seagrass yang ditemukan di Bali. Uniknya, antara bagian utara dan selatan Bali, secara ukuran morfologi ada yang terlihat berbeda. Ini adalah contoh dari Enhalus acorides yang di sebelah kiri saya temukan di daerah utara lebih ke barat. Ini tingginya sekitar, panjangnya sekitar 155 cm lebih. Sedangkan di daerah selatan Bali itu sekitar 60 cm panjangnya. Dan Halophila ovalis memang agak sedikit sulit untuk membedakan jenis Halophila ini. Yang kami temukan Halophila ovalis di perairan Bali, kisaran panjang daunnya itu sangat lebar. Dari 12 sampai sekitar 30 cm. And how seagrass threads in Bali? Beberapa sudah disebutkan oleh Pak Mike sebelumnya. Threads yang terjadi di dunia khususnya, dan ada beberapa contoh yang Pak Mike ambil di daerah Bali. Dan saya list beberapa ancaman yang bisa terjadi pada seagrass di Bali. Yang pertama adalah reklamasi, kedua sedimentasi dan pendangkalan perairan, lalu pencemaran, fishing atau penangkapan ikan, kapal, dan yang specifically saya lihat di Bali ada kesalahan peletakan dari coral transplantation yang harusnya diletakkan di daerah karang atau di daerah terumbu karang, diletakkan di daerah seagrass. Lalu yang terakhir adalah tourism. Ini contoh dari reklamasi yang terjadi di Bali. Ini salah satu pulau yang ada di Bali. Asal luas pulaunya itu adalah 112 hektar. Setelah direklamasi, dia bertambah 379 hektar. Yang warna hijau ini adalah pulau aslinya. Yang warna coklat ini adalah reklamasi yang terjadi. Dan reklamasi ini pasti akan menyebabkan seagrass yang ada di daerah sebelumnya menjadi hilang. Selanjutnya adalah sedimentasi dan pendangkalan perairan. Sebelah kiri ini adalah pendangkalan perairan yang terjadi di Teluk Benua Bali. Dan sebelah kanan saya mengambil paper dari Tanto et al. Dia mengatakan pada tahun 2015 luasan sedimentasi menjadi 1.966 hektar. Dan ini menurut saya sangat cepat. Dan dari yang saya lihat di daerah Teluk Benua, di dalam Teluk Benua, saya tidak menemukan, saya hanya menemukan satu seagrass di daerah Kelan, di sebelah kanan dari Teluk Benua, dan sepanjang ini tidak ditemukan seagrass lagi di sana. Selanjutnya, polusi air atau pencemaran dari air. Ini penelitian yang dilakukan oleh mahasiswa kami. Dia meneliti kandungan logam berat kadmium and plumbum atau timbal di dalam tubuh seagrass. Dia mengambil sampel dari daerah selatan, ini Pulau Serangan, di daerah selatan Pulau Serangan, atau ini tempat keluar masuknya kapal menuju pelabuhan Benua Bali. Dan hasil yang ditemukan cukup mengejutkan, karena bila dibandingkan dengan baku mutu ini untuk biota, karena kami tidak menemukan seberapa logam beratkah yang dapat diterima oleh biota tersebut, tapi kami membandingkan dengan baku mutu yang ada di Capman LH tahun 2004. Dan sangat jauh sekali. Dan ini juga saya bandingkan dengan hasil kerang atau logam berat yang diteliti oleh mahasiswa kami sebelumnya di benua ini juga. Dan ternyata kandungan logam berat di seagrass lebih banyak 3 kali lipat dibandingkan dengan di kerang yang ada di Teluk Benua ini. Dampaknya sebenarnya bukan hanya pada seagrass, tapi pada organisme pemakannya, seperti tukik dan mungkin ikan dan bivalves lainnya, yang tentunya kandungan dari logam berat ini akan masuk ke dalam tubuhnya, dan kalau ikan itu atau moluska itu dimakan oleh manusia, tentu logam berat ini akan masuk juga ke tubuh manusia. Selanjutnya ini tadi foto yang sudah ditampilkan oleh Mike. Ini penangkapan ikan di daerah Sanur. Sebenarnya penangkapan ikan di Bali tidak hanya seperti ini. Cuma saya tidak mempunyai foto untuk di-share. Banyak nelayan atau pencari ikan hias di Bali itu menangkap ikannya itu di daerah Seagrass. Lalu ini juga sudah di-share oleh Mike, akibat dari kapal, dari baling-baling kapal yang terjadi di Lembongan. Ini tadi yang saya sebutkan, peletakan dari meja transplantasi atau melakukan rehabilitasi terumbu karang, tetapi di daerah Seagrass. Gambar di bawah ini hanya sedikit Seagrass yang terlihat. Yang hijau di atas sebelah kanan, ini adalah meja transplant yang ditutupi oleh alga. Keberadaan dari meja transplant di sini, selain dia bisa langsung mematikan dari Seagrass, secara tidak langsung Seagrass yang berada di bawahnya tidak bisa terkena cahaya matahari atau tidak bisa melakukan fotosintesis karena tertutupi oleh meja transplant ini. Ini kami temukan di daerah Uluwatu, Bali. Dan mass tourism sebagai daerah pariwisata, ini gambaran dari salah satu tempat wisata di daerah Tanjung Benua, Bali, di mana di bawah perahu tersebut itu adalah Seagrass semua. Jadi bisa kita bayangkan betapa terancamnya ekosistem Seagrass yang ada di sana. So, apa yang harus kita lakukan? Ya, kalau dari saya, saving the earth starts with you, atau dari diri kita sendiri untuk membantu melindungi dari bumi ini dan khususnya ekosistem Seagrass. Terima kasih. Ini presentasi akhir saya. Saya kembalikan ke moderator. Terima kasih Pak Giri.
Terima kasih Bu Elok. And now we will move to the last speaker. The fourth speaker will be Professor Ricardo F. Tapilatu. Prof. Rick is a professor in marine biology and conservation at the University of Papua. He is also the head of the Research Center for Pacific Marine Resource at the University of Papua. The Research Center is a state education and research institution that seeks to understand and protect the pristine ocean life of the bird-head seascape through the research and conservation initiative. At the regional scale, Prof. Rick is also a co-regional vice chair for the Australian IUCN Marine Turtle Specialist Group and a member of the IUCN Marine Conservation Committee. And today, Prof. Rick will share with us about the seagrass at the Birdhead Seascape, Papua. Prof. Rick, are you ready to share your works?
Yes, I'm ready.
Yes, please, Prof. Rick.
Good day, everyone. It is my pleasure to give a talk from the most eastern part of Indonesia. So, as you know, I'm Ricardo Tapilatu, or just call me Rick. And today I'm going to talk about seagrass at Birdhead Seascape, Papua. And my talk touches the aspect about the biodiversity, the roles and threats locally here in Papua. How to move. Sorry, Pak Giri, I didn't have access to move my screen. Oh. Pak Giri? Wow. Please give me access to control.
You can try now, Rick.
Yes. Yep.
Is it okay?
Yep.
Okay. Go on.
Yep. So actually, I'm not a seagrass expert, but I'd like to share about my knowledge and my experience working with partners related with the seagrass and one of the partner that we are going to start to do the survey and research here in Papua is with Dr. Mike from Modern University. Sorry, please someone mute the intruder.
Dari Bapak Agus Widayanto kepada Ibu Kepala Dinas di Rumah.
Halo, Mas Giri itu, could you?
Pertanyaannya Bu, berdasarkan Permen nomor 47 tahun 2016 tentang pemanfaatan kawasan.
Okay, Parik, please.
Okay, can you stand by there so then you can control Pak Giri?
Yeah.
Yeah.
My team are already stand by here. I'm sorry for the inconvenience, Parik.
Okay, yes. Seagrasses are the key primary producer habitat in many coastal environments globally. Their productivity and structural complexity provide food and shelter for many associated species, including important iconic megafauna and fishery species. In this way, seagrasses are important for cultural reasons and subsistence, artisanal and recreational fishing. Seagrasses also help to maintain sediment stability, as Mike and then also Pak Andreas explained about the roles of seagrasses. So they maintain sediment stability, preventing coastal erosion, and playing an important role in biogeochemical cycling and storage, including sequestration of blue carbon. In some places, 1 acre of dense seagrass can sequester more than 12 pounds of carbon per year, equivalent to the amount emitted by a car traveling about 10,000 kilometers. So more than twice the distance across the US from the US West Coast until US East Coast, for example. So each year, seagrass meadows absorb about 10% of the total estimated organic carbon sequestered in the oceans. I repeat it, this is important. Each year, seagrass meadows absorb about 10% of the total estimated organic carbon sequestered in the ocean, as we saw in presentations of Andreas. So, same slide with Andreas about the distribution of seagrasses around the world. We are in the center of the global biodiversity of seagrasses because we are located in a coral triangle and we have so many diverse seagrasses. But as you can see, the next slide, please. Yes.
Wait.
Yes. As you can see in the slide, I circle Bird's Head Seascape. So Bird's Head Seascape is the epicentrum of global marine diversity located in the heart of Coral Triangle, which is in Papua Barat Province. So in Holland-speaking they say Vogelkop, but in English they say bird's head, and in Indonesia we call it kepala burung, Papua. So Bird's Head Seascape lies in the center of biodiversity for seagrasses, with 10 species reported by Mackenzie et al. 2007. But little is known about the distributions, ecology, condition of seagrass beds in this region. Seagrass occurs in Bird's Head Seascape, located in 4 main habitat types. The first one is estuarine, coastal, reef flats, and deep water. Deep water seagrasses are the least understood but nonetheless ecologically important because they are generally dominated by Halopila, the main genus eaten by dugongs. In the eastern Bird's Head Seascape, extensive seagrass beds are found around Biak, Padaido, Yapen Islands, while in the south of Bird's Head, seagrass beds are found in Arguni, Kayumera, Etna Bays near Kaimana. Next slide, please. Seagrass beds are important habitat for rabbitfish or Siganidae, an important subsistence and small-scale commercial fishery for local communities. The associated animal species are important to local communities as a source of food, and the ecosystem support a range of endangered or vulnerable megafauna such as sea turtles and dugongs. So over recent decades, considerable research has gone into developing techniques to reduce the loss of seagrass, like Mike mentions about his experience and surveys in Australia, and to restore areas that have been damaged in Australia, in Western Australia. So, learning from this, most of this research has been undertaken in developed countries like Australia and then US, with the seagrass resources of developing countries such as Indonesia often being unreported and poorly surveyed. But here in this slide, you can see LIPI, the Research Center for Oceanography, started the survey in Raja Ampat. They assessed the seagrass in north of Sulawesi, Salawati. So there are 4 main big islands in Raja Ampat. So they survey north of Salawati and that eastern part of Batanta Islands and several in West.
Tanggapan terhadap pertanyaan dari Pak Agus.
Next slide, please. Yes. In addition to LIPI, several colleagues and students at University of Papua and also partners work in multiple surveys. As you can see here, our college, Fani Talakua, Ibu Fani Talakua, and then also Ibu Manangkoda from forestry department, but her survey about seagrasses they conducted the survey and identified 12 species in Manokwari and Cendrawasih Bay. But as I already mentioned, Mackenzie et al. 2007 identified 11 species in Birchhead seascape. And then my other college studies specific about the content of heavy metals in seagrass. The species is Columpilla rotundata. As you can see here, the morphology of the 12 species found in Manokwari and also in Cendrawasih Bay. So overall, our research with others indicate that seagrass ecosystem of Raja Ampat and also Birchhead Peninsula are typical of Indo-West Pacific tropical seagrass communities with high biodiversity and abundance in shallow coastal waters. And as we can hear from the previous presentations, most of the seagrasses distribute in the tropical region, and here in Pacific, we reported at Birchhead, we have a typical of Indo-West Pacific tropical seagrass communities. Next, please. Yes. In Raja Ampat, the islands of Sayang, Kauai, Waigeo, Batanta, and Salawati. Sorry, I didn't present the map over here, but this is the area with other islands, smaller islands, support seagrass beds that are important as a foraging site for green turtles. So, green turtles is a keystone species. What is the keystone species? A keystone species is a species, either carnivore or herbivore, that plays a major role in determining the community structure to prevent resource monopolizations by a single species in a community. The removal of such species causes dramatic changes. Sorry, back to the previous slide, please. Pak Giri? Still, yes. The removal of such species causes dramatic changes, and sometimes these changes will cascade through the ecosystem. As you can see here in this slide, I put the green turtles eating the seagrass. So green turtle is a keystone species that would alter the community structure and dynamics of this habitat. How? Through their selective grazing activities or cropping, characterized by grazing plots that are sometimes formed. Here, green turtle functions as a natural disturbance, which is similar to storm waves, creating a situation which not only promote growth, but also prevents competitive exclusions by certain faster-growing seagrass species. The biochemistry also easier to digest and higher in nutritional nitrogen required for protein synthesis in herbivores. In contrast, other blades are contain more hard to digest structural materials through selective grazing. Green turtle maintains grazing plots full of young blades or young leaves that invest more of their available energy in nitrogen and starch than in structural components, which benefit not only sea turtles but also wide host of other micro and macro herbivores. As such, green turtles determine whether a seagrass habitat is a herbivore or detritivore dominated. Next slide, please. So, The second example about dugong. Dugong also play an important role as a keystone species like green turtles. Here, we identify Cendrawasih Bay has extensive lagunal seagrass. The Cendrawasih Bay is located in the southwestern area of the bay in birds head, which were reported to support dugong's populations. So here you can see they eat seagrasses by grazing and also algae and other plants. And they feed on bottom only, but they're not inefficient eaters because they have a hind gut that needs symbionts, and we are not so sure whether they feed on seagrass in daily basis or not. Next slide, please. So what is the threats impacting the seagrass in birdshead seascape? As we know, global seagrass coverage is diminishing at a rate of 1.5% a year, or about 2 football fields each hour. Can you imagine? 2 football fields each hour. Estimates suggest that 29% of seagrass meadows have died in the past century. Unregulated coastal developments and other human activities have resulted in severe damage to seagrass meadows and risk the sustainability of our coastal habitats. Several risks were identified or observed here at Birdshead for impacting the coastal seagrass ecosystem, in particular coastal developments. For example, road construction. As you know, the central government is developing the Trans-Papua Road to connect between the most western part of Papua to the most eastern part of Papua. And then other coastal developments such as reclamation and deforestation. All these have resulted in increased coastal turbidity, as you can see here in my slides, because of the road development that causing the turbidity and sedimentation from runoff, as well as reclamations of shallow coastal habitats that smoother seagrass beds, resulting in localized loss of seagrass habitat. But we are not so sure about the extent of the area that have been damaged. This may have a significant socio-economic impact for coastal villages that rely on seagrass meadows as a source of food. As I mentioned before, the seagrass meadows is a habitat for herbivores and for fishery. So all the threats will impact not only the habitat ecologically, but also economically for the coastal communities. So what is our recommendations? So we hope that in the future we can work with partners such as Dr. Mike Van Kullen from Murdoch University, and also with colleagues from Udayana University, and also federal government represented by Maritime Minister and Investigations like Andreas Hutayan. Here, I just want to recommend a few things. Please move to the next slide, Pak Giri. The last one. Yes. So new research is helping to close this gap in Raja Ampat and also the birdshead seascape of Indonesia. So by mapping seagrass biodiversity, abundance, and distribution, and identifying key threats to these ecosystems. Mike from Murdoch will be working with us, but I think next year, because we postponed our collaborative work twice. The first one in October, and then the second one in April this year. But because of the conflict in Papua around August last year, we have to reschedule. We reschedule in April, and then COVID-19 show up, and then we have to reschedule again. But hopefully the third one, no more reschedule. We have to work together, probably in early 2021. So we will be working by using Seagrass Watch methodology to assess the extent and health of the region's seagrass ecosystem, as well as risk of seagrass from natural and human impacts. We will be using food web dynamics from the Smithsonian Institution-led marine geomethodology. And next recommendations, we need to endorse the community or encourage the community awareness and outreach to share the good, to tell the low coastal community about the importance of seagrass ecosystem as a natural infrastructure, carbon sequestrant, fisheries, and so on. And learning from our experience and observations, the coastal developments can be done, but we need to buffer so the impact of the coastal development would be minimized before entering the coastal habitats. And then also we need to tell the people to minimize the coastal pollution by marine debris. And the last one, I would suggest that Indonesia should set an important day for seagrass. So we recommend that Indonesia should have like a Lemon Day in the future. I think that's all of my presentations, and I give the time back to Pak Giri. Yes.
Ya, terima kasih Pak Rick. So all of the speakers already finished their presentation, and maybe the speakers can take a breath first, or doing a little exercise before we continue to the question and answer session. So I already checked the participant who has sent their question to the YouTube channel and Zoom chat room, but unfortunately we only have time, maybe in 30 minutes. Only 30 minutes. We have a very limited time, so I will choose randomly the question from the YouTube channel and the Zoom chat room. So the first item will be given to Hasriani Hafid. So please, Hasriani Hafid, are you still in there? Hasriani Hafid. Okay, we move to the another participant. Hayati Suprapto. Please, Hayati Suprapto, mention your question directly to the speaker. Halo, Hayati Suprapto. Apakah masih mengikuti? Hayati Suprapto. Okay, to the next participant, Aulia Zentrinanda. Are you still in there, Aulia?
Yes.
Yeah.
Yes.
Okay, good. So mention your question directly to the speaker.
So I want to ask about, well, yes, thank you for the change. I want to ask how you determine the or distinguish the coral reef area and between the coral reef area and the Seagrass area. Thank you.
So Aulia, what is your institution? You can mention it before me, maybe.
Oh, I'm Aulia from Institut Teknologi Bandung.
Okay. And to whom your question is addressed?
The second presenter.
Okay. Pak Andreas.
Bu Elok.
Oh, Bu Elok. The third speaker, Bu Elok.
Yes.
Yeah, please, Bu Elok.
Okay,
Thank you.
thank you, Aulia. Sorry, I can speak bahasa. Okay. Kita bisa membedakan antara Seagrass area dengan coral reef area apabila di antara di daerah tersebut keberadaan dari Seagrass itu mulai sedikit dan terdapat koral yang sudah mulai muncul walaupun jumlahnya masih sedikit. Oke, for example, kalau untuk di daerah Bali, biasanya dari kebanyakan ya, tidak semuanya, ini tidak sama di setiap tempat ini. Dari pantai itu sudah mulai muncul Seagrass, kurang lebih ke arah laut itu sekitar 150 meter. Ketika si koral itu sudah mulai memunculkan dirinya dan si Seagrass jumlahnya itu sudah mulai sedikit. Jadi itu adalah zona peralihan antara Seagrass dan koral. Kalau tadi yang saya sebutkan peletakan transplant koral yang harusnya di tempat koral, karena itu telah kami survei, sebenarnya itu adalah video yang kami buat. Peletakannya itu memang jelas masih di daerah Seagrass area. We cannot find any coral in that area. So karena itu kami di tim kami mengatakan memang itu salah penempatan untuk transplantasi koralnya. Mungkin itu yang bisa saya jawab. Terima kasih Pak Giri.
And then for the next question is from Febrian Korwa. Febri Ferdian Korwa, are you still in there? Febri?
Yes, I'm here.
Yeah, okay. Please mention your question. Before that, you can mention your institution. And the question is addressed for whom? For who? Okay, yes, please.
Baik, yang saya ingin tanyakan kepada Bapak Andreas terkait dengan stok karbon yang terdapat pada setiap tipe sedimen seperti lumpur, pasir, dan pecahan karang. Apakah stok karbonnya sama atau berbeda? Kalau berbeda, faktor apa saja yang menyebabkan sehingga stok karbonnya berbeda pada berbagai sedimen? Terima kasih.
Ya.
Mohon maaf, saya potong. Untuk asal institusinya, Bapak Feldi, dari institusi mana?
I'm from University of Papua.
Okay. please Pak Andreas.
Feldi, muridnya Pak Rik ya.
Ya,
Jadi begini, tadi di awal tadi saya sudah mengatakan bahwa blue carbon itu adalah karbon yang diserap melalui proses fotosintesis oleh vegetasi yang ada di ekosistem pesisir. Apakah seagrass, mangrove, phytoplankton, atau atau yang lainnya seperti ada juga seaweed dan sebagainya. Nah, di pantai di kawasan pesisir ada berbagai bentuk substrat. Tadi yang dikatakan tadi oleh Feldi ya, ada dari ada yang lumpur, ada yang pasir dominan, ada yang koral. Nah, tentu saja kandungannya ini berbeda. Karena apa? Karena vegetasi yang tumbuh juga di situ juga berbeda-beda, dan baik jumlah, intensitas maupun abundance-nya. Seperti contoh, misalnya di daerah yang berlumpur, itu kita ada koral, ada tanaman mangrove. Itu saja kandungan karbonnya lebih besar dibanding di daerah pasir yang notabene misalnya seagrass ada di sana. Karena memang jarang mangrove ada di pasir ya, tapi memang 1-2 ada aja gitu ya. Apalagi di coral reef kan itu kalsium karbonat. Kalsium karbonat itu adalah anthozoa, binatang. Jadi coral reef itu binatang, dia tidak melakukan fotosintesis, justru melakukan respirasi. Sama kayak kita merespirasi, menghirup oksigen yang diambil melalui mutual simbiosis antara coral reef dan zooxanthella. Jadi zooxanthella yang menghasilkan fotosintesis, menyerap CO2 dan merilis O2. Dan kemudian O2 diambil oleh anthozoa, si polip koral ini, untuk tumbuhannya. Dan ketika dia mati gitu, dia akan menjadi ya udah kalsium karbonat. Ini beda lagi prosesnya, bukan dalam hal ini karbon stoknya pasti akan sangat rendah di daerah terumbu karang. Itu yang pertama. Itu jika kita mengkategorikan bahwa sumber karbon itu adalah dari ekosistem itu sendiri, atau yang sering disebut autotonus. Tetapi jika karbon itu berasal dari luar, seperti ada pengaruh dari sungai atau river runoff, tentu saja daerah berlumpur cenderung organik karbonnya lebih tinggi. Kenapa? Karena emang dari banyak aktivitas manusia yang ada di sekitar situ, seperti di daerah mangrove. Itu lebih banyak aktivitas manusia dibanding dengan di daerah Seagrass misalnya. Ada river runoff membawa partikel organik karbon ke daerah ekosistem mangrove. Nah itu perbedaannya. Jadi yang Feldi bilang tadi ya benar, itu beda antara karbon yang ada di ekosistem lumpur, seagrass juga ada di ekosistem lumpur, atau yang ada di ekosistem pasir, dan ada yang di ekosistem terumbu karang. Seperti itu. Menjawab, Feldi ya?
Baik, terima kasih Bapak menjawab.
Yes, we will continue to the question from the YouTube channel. There is also a lot of questions, and yeah, the first question might be addressed to Dr. Mike. The participant who asked this question is Nur Samsi. He asked about how long that we need to doing the transplantation, and when the transplantation is we call it a success. That was the question.
So it depends. Thank you for the question. The amount of transplantation depends on the area that has been damaged. If you plant seagrass maybe half a meter or 1 meter apart, they will grow together. And so you don't need to transplant every few centimeters. You can plant spread apart and then they will grow together. So that makes it easier, but many of the areas where we have lost seagrass are hundreds of hectares, and it takes a lot of effort to transplant a small area. So that is why we are looking at seeds and seedlings and not necessarily transplanting just small pieces. For understanding how long we need to wait until we know that we have success, normally we wait for 5 years. 5 years is a good time to monitor the seagrass that we have transplanted and see if it has survived. I think in tropical areas, so this is from my work in temperate areas, so slower growing seagrass. I think for tropical areas, somewhere between 3 and 5 years would be long enough to know if you have been successful. We need to wait until the seagrass is well established and can survive storms that could wash them away. So for us, 5 years is enough to know that the seagrass can survive, but maybe less for tropical areas.
Yeah, thank you, Dr. Mike. And the next question, I think it is an interesting question from Fahri Ramadian. So Fahri asks if all the ecosystem, mangrove, coral reefs, and seagrass is damaged, which one will be the priority for the restoration? Maybe all of you can give an answer for this question. So maybe Pak Rick can give explanation about this question. Udah nyala. Saya ulangi lagi, apabila semua ekosistem di pesisir mengalami kerusakan, mangrove, terumbu karang, dan seagrass, sebaiknya ekosistem mana yang harus didahulukan untuk dilakukan restorasi? Mungkin Pak Rick bisa memberi jawaban atas pertanyaan ini. Halo Mike, can you hear me?
Yeah.
Pak Rick? Pak Rick, are you still in there?
Yes. Sorry. I'm still unmuting my phone. Yeah.
Okay, please, Pak Rick.
This is three important habitats or ecosystem. They are connected to each other. So in this case, I think we should do the conservation or rehabilitation simultaneously, not a priority for like a coral reef or for mangrove or for seagrasses, because in coastal habitats, in some of the a few part of the coastal habitats, they always have three ecosystems. So in this case, if they all damaged, we need to work simultaneously. So we need to deploy volunteers to work for the coral restorations, and then also for seagrass restorations and mangrove ecosystems. If we just prioritize only for one ecosystem, probably it would be too late for us to work. So I guess we need to check the the historical configurations of the habitat. If there were three habitats in that site, so we need to work simultaneously. I guess that's all from my experience.
The next question will be on the Zoom. Margareta. Ibu Margareta, are you still in there? Ibu Margareta? No? So next question, Ardan Seman. The question is for Proprik. So Ardan, Pak Ardan, apa masih bisa mendengar saya? Okay. So the question is for Professor Proprik. So what is the effect of global warming on change in standing crop and change in the morphology of seagrass, and how can they be measured? Please, Proprik.
I think if we follow the presentation from Dr. Mike van Keulen, it is clear about the, I think it will be more detailed if we see and then we follow the presentation from Dr. Mike. Or probably Dr. Mike, can you help me out with the questions?
Yes, no problem. So, sorry, I've lost the question. Can you ask the question again?
The effect of the global warming on change of in standing crop and change in the morphology of seagrass, and how can they be measured?
Okay, so what we're finding so far is that global warming doesn't have a big effect on seagrass. So far, the seagrasses have not reached a critical temperature like we see with corals. So seagrasses at the moment are looking okay for temperature. We have had some cases in Western Australia where we had a very strong marine heat wave that caused some of the seagrass to become very stressed and die in places like Shark Bay. But I think that is unusual, and it was in combination with other factors. So there was flooding and a lot of turbidity. So the seagrass was stressed by many different things together. Morphology, I haven't seen any changes in morphology either so far. The major problem that we anticipate for seagrasses under global climate change is where we have sea level rise, and as the sea level rises, there is no habitat for the seagrass to move into. If we have small sea level rise and there is enough habitat for the seagrass to grow into, that's okay. But if there is nowhere for the seagrass to go to grow next, then that becomes a problem, and so we could lose seagrass. What we are expecting is that at this stage, what we are expecting is that as we lose seagrass, there will be other places where seagrass will be able to grow. And I think that will be particularly the case in the tropical regions where the seagrass grows quite quickly and can take advantage of new opportunities. Giri, I think your microphone is muted.
Okay, I'm sorry. So the question is oh, Dimas are already online. Please, Dimas, you can ask directly
Okay.
to Dr. Mike.
Okay. Thank you for the my I don't know what to say, but thank you for Mr. Mike for answering my question in the chat room. So I think I will move to the next question. Is for Mr. Rick and Mr. Andreas. First, I am Dimas Badendaru from Institut Teknologi Bandung. Okay, so the question is for Mr. Rick. Is there always exist dugong or manatee in every seagrass species, or it's just few species of seagrass that have the dugong or manatee in there? And for Mr. Andreas, after we know carbon storage in water and sediment, so what is the contribution and also the benefits of with knowing the carbon storage? I'm sorry, I still cannot understand comprehensively. That's all. Thank you.
Yes.
Michael. I'm sorry, Pak Rek. So the first question, yeah. The first question for Mike, yeah. Mike already answered the question directly to Mas in the chat room, but there's any other participant who joined with us in the Udayana TV and YouTube channel, maybe they can hear or they don't know the answer of the question. Maybe Dr. Mike would the answer first the question in the chat room.
Okay.
Yeah, Dr. Mike, can you hear me to answer the question in the chat room, because the audience are already in the YouTube channel and the Udayana TV too, not only in the Zoom channel.
Okay, sorry, I've been answering quite a few questions in the chat room, and I don't know which question you want me to answer here.
Yes, I can see clearly that Mike, you answer almost all of the questions.
Yeah. Huh? Yeah, but the question is only for participants who join with us in the Zoom channel. But
yes, which question do you want me to answer?
So maybe I could repeat my question, maybe?
Yes, please.
Okay. So for all of speakers, especially Mr. Mike Van Keulen, what I want to ask is, first, is there any recent progress among seagrasses watchers, scientists, and government to create a protocol or law enforcement about saving seagrasses, especially in Indo or Pacific area? That's all.
Okay, so there are different countries have different protocols in place, and it depends on which country on what protection is available. I was in the Maldives last year, and we set up a new seagrass monitoring program there, and we're hopeful that that will turn into long-term protection for the seagrass. I can't speak for other countries. Obviously, Australia seagrass is protected, but you know that will depend on which country you're actually talking about.
Okay, let me add one more thing about the seagrass bed in Raja Ampat. So in the north of Miso, we have established a new marine protected areas, but with different style. We call it the Adat Marine Protected Area. So this is like a cultural things. And in that area, north of Misol Island, we have the seagrass meadow, and we have at least 8 dugongs. So the not manager, but the area is patrolling by the local communities, and they monitor the presence of dugongs, and they maintain the area not disturbed by the either local or outsider who might come with destructive fishing practices like a bomb fishing to uh, to damage the area for short term, and not only short term but also for long term damage. So here, from our experience, Raja Ampat established the patrolling system and to monitor the dugong, but at the same time also the habitat for seagrasses in their area. Thank you.
Thank you, Prof. Rick. Maybe Pak Andreas also have a suggestion regarding to the law enforcement.
Yeah, I think for the law enforcement, it's difficult if we are talking based on the species, but maybe based on the region. For example, in one protected area, if we already established, there are many. It's not only including. It's not only for seagrass ecosystem, but also there will be another ecosystem like a mangrove or coral reef as the one. What we call it as one community, something like that. So once we protect the area becoming the protected area, and then of course the law will be applied in that area. But it is difficult usually to apply a specific law only for seagrasses. I mean, something like that. Yeah. And also, another of your question, Dimas, regarding what is the importance of the carbon. I mean, why is we need to care about the blue carbon of the seagrass? Because maybe you know already that that our ocean absorb at least about 40% of the anthropogenic CO2. So they are being absorbed by the ocean through different ways. One is through the land, river runoff, something like that, and another is from the surface atmospheric interaction. And once the CO2 being absorbed in the water column, then they need some way, some mechanism how to process this CO2, becoming another material that can be useful for another organism, something like that. The ways, one of the ways is using the what we call it the photosynthesis process, how the vegetation, coastal vegetation, could absorb the CO2 from the water column, and then they release the O2 that can be useful for the marine organism. And this kind of number of the observation is very important when we dealing with the UNFCCC regarding to the importance of the ocean for mitigation of climate change, something like that. So on the UNFCCC discussion, usually we could able to bring the issue how significant contribution of the seagrass, something like that, for mitigate or for controlling our CO2 in this particular area, something like that. So this is what we call it. This is like scientific evidence or scientific based policy how we could able to manage the seagrass ecosystem in the proper way, and can be linked as well to the law in particular area or in the in global direction, something like that. Thank you.
Oh, Pak Giri, sorry. Pak Giri.
Pak Giri itu di
Ya.
Yeah, Pak Giri.
Ya.
Sorry, there is one question from University of Cendrawasih in Jayapura. So, I don't know, probably Mike, can you help? This is about the freshwater plants. In Papua, we have a seagrass in freshwater, and the species is Syringodium with the same morphology in the salt water. How we can differentiate the species? Is it different species or same species? Morphologically are the same, but probably genetically, can you explain? And probably you familiar with the species?
Yes, I know Syringodium. I wasn't aware of it growing in freshwater. I've only seen it in marine water. So there are similar freshwater plants that look physically similar to Syringodium. So maybe you need to check very carefully that it is Syringodium and not something else. Syringodium may also grow in estuaries, so if it is not completely freshwater, maybe it can survive there.
Oh, okay. Yeah.
Yeah, okay. For the next question is from Rob Perryman. He asked to Mike.
Oh, Mike already explained to him.
Okay.
I can explain it again.
Okay. Who's next? Pak Denny, please, Pak Denny.
Yeah. Thank you, Pak Hendrawan. Actually, my question has been asked to to Mike by Professor.
I'm sorry, Pak Denny. I think there's a problem with your connection. Halo, Pak Denny. So we lost the connection with Pak Denny. So the question from Rob Perryman. The question is for Mike. What is the investment in time and number of people required to restore 3 hectares of seagrass? Please.
Okay. So the way that we transplanted the seagrass is by taking a piece of rhizome and transplanting it to a new area. That is a very slow process. So our process we did over 3 summers using volunteers and just 1 boat. I think if you use different methods, for example, seeds or seedlings, you could probably do that much more quickly. We are also restricted by the time of year that we can transplant. So we can only transplant in summer when the weather is good. Once we start having storms during winter, it becomes more difficult to work and the seagrass are easy to wash away. So we are restricted to only 3 months in which we can transplant with the seagrass surviving. So it took us 3 years to do the 3.2 hectares.
Hello.
Yeah, thank you, Dr. Mike. Yeah, we still have a couple of minutes, so I will give a chance to Pak Denny. Please, Pak Denny.
Oh yeah. Thank you, Pak Gede Hendrawan. My question addressed to Mike, Professor Mike. I have a question, Mike. Is there any method to identify a seagrass in the nature by using satellite photo? Because maybe like another plant, I mean, satellite photo can be used for identifying the species or the genus of the plant. Can the I mean, is there any method on seagrass to identify the seagrass species, Mike? Thank you.
That's very difficult. But yes, I think once we train the software to analyze the photos, we can probably use satellite and maybe drone footage to identify the seagrass. It's going to be difficult because some of the very small seagrasses are very hard to see from satellite or remote sensing. But we should be able to identify differences in the texture of the photographs and therefore look at big changes between seagrasses. So, for example, in an halos meadow would look different from Halophila meadow, but we may not be able to see all of the different species clearly.
Can I add?
Thank you, Mike.
Yeah. Danny, I guess it might be a challenge to develop the technology. So with aerial survey using drone, they use like a sensor to detect the species. So if we have more species of mangrove, we need to make a more sensor to detect based on the leaf or things, so then the sensor can identify the species. So it still takes time to survey using the aerial, with the satellite. Even though with the drone, probably still difficult because they are underwater.
We have done some work using hyperspectral photography flown on a plane. That allowed us to differentiate between different types of coral communities versus bare sand versus seagrass. And I think if the system is refined enough and trained enough, we can probably start to separate some of the species as well. But as you said, anything underwater becomes very difficult. We need very clear water or intertidal seagrass we could probably do without too much trouble. Pak Denny, you're muted. Your microphone is off.
Yeah, thank you, Dr. Mike and Prof. Rick. So we are already run out of the time. So the question and answer session, we close the question and answer session. And at this the end of the seminar, I would like to hear the closing statement from each of the speakers. Maybe we can start from Dr. Mike. Please, Dr. Mike.
Thank you, Pak Giri. I've found this a very useful seminar. It's great to see so many people interested in the seagrasses. Obviously, there are many things that we can still learn about seagrasses here. And I think it's important to recognize that we can make a difference to the seagrasses at a local scale that will improve their survival at a larger scale. So keep in mind that the seagrasses are important. We can protect them, and I think that will make a difference to our coastal environments.
Yeah, thank you, Dr. Mike. Please, Pak Andreas.
Yeah, I think this webinar is very important for all of us since many of the, we call it oceanographer or marine biologists are mostly care about something big like coral reef or mangrove, rather than important ecosystem in the between of both ecosystem. So handle or restore the seagrass ecosystem is a key for solve the problem of both ecosystem. Both ecosystem means is mangrove on the land and then coral reef toward the ocean. So I think this meeting is the important to enhance our understanding and care about the importance of seagrass for our daily livelihood. Thank you.
Thank you, Pak Andreas. Ibu Elo, please. Bu Elo?
Yeah, yeah. Thank you, Pak Giri. I'm happy to be one of the presenter in this webinar because more people know seagrass, and so more people can love and save them. So we can keep the ocean healthy. That's it, Pak Giri.
Yeah, thank you, Bu Elo. Rob Fick?
Yes, so learning from this webinar, I've been doing survey, but mostly with other taxons, mostly with marine megafauna actually. And little is known about seagrass. And from our webinar today, I learned that seagrass is so important for our coastal and ocean communities. So now we have connections, like a Mike from Western Australia, and then Andreas from federal government, and then also developed from Udayana University. How the webinar can trigger us to move forward, to work together, and join force to survey and then to do research to fill in the gap that we don't know so far. Because if we just work by ourselves here in Papua, probably it's not so optimal, it's not so efficient. So we need to learn from the expertise from other countries like Mike, and then we need Andreas from the federal government to also pay attention to the most eastern part of Indonesia or in central Indonesia to work together. So that's all that I learned from this webinar. There should be a follow-up, not only talk, but also actions to restore our seagrass meadows in Indonesia.
Yeah, thank you, Pak Rick. So regarding to this topic, I have made some note. First is seagrass has a potential to mitigate the climate change by absorbing the carbon, like Pak Andreas already said. But the threat is also many, and it seems to happen around the world, including in Bali and in Papua, as Bu Elok and Professor Rick already said. But fortunately, the seagrass ecosystem also can be rebuilt by doing the transplantation, as Dr. Mike already already has so many works in Australia. And Propric also highlight that many organisms, including micro or macro organisms, are depends on the seagrass ecosystem. Baik, demikian webinar kali ini, and all of the speakers are very happy to share their material to all of the participants. So we will send the link of the material to all all of the participants. Dan jangan lupa untuk semua partisipan agar mengisi absensi yang sudah disediakan oleh panitia. Ya, untuk link dari materi dari presentasi dari masing-masing presenter itu bisa dilihat nanti di website JMRT atau Facebook fanpage. Jadi demikian seminar kali ini. Saya ucapkan terima kasih kepada seluruh presenter, kepada seluruh moderator, dan juga panitia yang telah mendukung kesuksesan acara hari ini. Saya tutup presentasi hari ini. Selamat siang dan sampai jumpa.
Terima kasih.
Terima kasih semuanya. Thank you, Mike. Thank you, Prof. Rick. Thank you, Pak Andreas.
You're welcome.
You're very welcome.
Thank you, Pak Riki.
Right.
Thank you.
Thank you, Mike.
See you later.
Bro. Andreas, terima kasih.
Sampai ketemu lagi, Pak.
Terima kasih, Ella.
Om Swastiastu, salam sejahtera. Saya, Rektor Universitas Udayana, menyatakan bahwa Universitas Udayana berkomitmen penuh melawan penyebaran virus COVID-19 dengan beberapa langkah. Yang pertama, Universitas Udayana telah menyiapkan dasar regulasi aksi dengan menerbitkan instruksi rektor tentang pencegahan, perkembangan, dan penyebaran COVID-19 di Universitas Udayana. Kedua, Universitas Udayana telah membentuk Satgas Pencegahan COVID-19. Ketiga, Universitas Udayana melalui Satgas telah menyusun dan menyebarkan panduan pencegahan, protokol, dan SOP yang berlaku di Universitas Udayana. Keempat, Universitas Udayana juga melakukan aksi nyata dengan menyebarkan hand sanitizer ke seluruh unit di Universitas Udayana, penyemprotan atau sterilisasi serentak pada gedung dan ruang di lingkungan Universitas Udayana, menyediakan layanan konsultasi, pelaporan melalui call center dan hotline di nomor 0361 895 3670. Untuk kegiatan belajar mengajar telah dilakukan melalui sistem online. Tenaga kependidikan pun telah diterapkan bekerja dari rumah. Saya selaku Rektor Universitas Udayana menghimbau kepada seluruh sivitas akademika dan masyarakat umum untuk mengikuti protokol pencegahan yang dikeluarkan oleh pemerintah seperti mengurangi kegiatan di luar ruang, social distancing, rajin mencuci tangan, dan selalu menjaga kesehatan. Demikian saya sampaikan, salam sehat selalu. Om Santi 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 Om.